of the proof videos. So again, I know I've said it a million times, but I really hope you guys are getting a feel for how these five little things can help you on these proofs, and hopefully you guys are filling in this note page and have the definition of the shapes and have an understanding of kind of what this evidence does and what you can do if they tell you the angles are vertical and what you can do if you have an angle bisector, etc. It's just so important to have all this down, and if you don't, these proofs get really difficult. And again, I would just ask you to prove this on your own. Pause and then see how far you can get and go from there. So given is the picture. That's really what's given. And then they're asking to prove this. So hopefully you can do this. Go ahead and pause it and see what you come up with. So I will say that BC is congruent to AB. I know that's given. And I will say that CD is congruent to AD. I know that that's given. I know that BD and BD is reflexive. I know I can say these triangles are congruent because of side-side-side congruence. And finally, I can come back and say that angle ABD is congruent to angle CBD. And I know that that is true because of CBCTC. So this is a really easy one. Hopefully you guys did okay with that and actually did it on your own. Alright, again, go ahead and pause. This one has 8 steps, and I'm going to make this one a little bit smaller. It looks like they'll all fit. But again, hopefully you guys will pause this and get as far as you can on it, and then I will go over it. Alright, so CD bisects AB at D is given, and I can say that AD is congruent to BD. I believe that is the definition of a bisector. Now I know that CD is perpendicular to AB, that is given, and I can say that ADC and BDC are right angles. That is the definition of perpendicular. All right angles are congruent. I guess I can say angle ADC is congruent to angle BDC. Now we're going to say CD and CD is reflexive. I believe I can prove triangle congruence here, so I'll say triangle ACD is congruent to triangle BCD because of side angle side congruence. And then finally, what we're trying to prove is that CA is congruent to CB because of CPCTC. Alright, so again, that was a lot of steps, but it wasn't too bad, especially with it, a lot of it already filled in. Again, hopefully you guys are pausing this and seeing how far you can go, and then we'll go from there. So FG is the perpendicular bisector of HI. We will say that is given. And now we know something got bisected. So FG bisected HI, so I think I can say HF is congruent to FI. That's the definition of a bisector. And we can say that HFG, angle HFG and angle IFG are right angles, because that's the definition of a perpendicular line. So I think that's just definition of perpendicular. Definition of perpendicular lines. Right, that was the perpendicular bisector, so that means with a 90-degree angle. So now I can say angle HFG is congruent to angle IFG, and that is all right angles are congruent. And this is pretty similar to the one we just did. So we'll say FG is congruent to FG because of the reflexive property. And again, now we have side angle side congruence. Triangle HFG and IFG. And now I can come back and say that angle H is congruent to angle I because of CP/CTC. So hopefully you guys are doing okay with these. Again, a lot of these are filled in, and if we use these steps, it makes it a lot easier, I think. Alrighty. We're given this picture, and we want to prove that BAC is congruent to DCA. So again, if you guys want to go ahead and pause where you're at and try this for yourself, I think this one's really easy. I think you can get through it very easily. Alright, so AB is congruent to CD. I know that's given. AD is congruent to BC. I know that's given. I know that I can say AC is congruent to AC because they're reflexive. And now I can say these triangles are congruent. So I'll say triangle ABC is congruent to triangle. So A is across from 2, C is across from 2, B is across from 3, D is across from 3, and then C is across from 1, so A is across from 1 because of side, side, side. And then finally, how do I know that angle BAC is congruent to DCA? I do because of CP/CTC. So I'm getting a lot of that CP/CTC today. And the last one. So again, I would love it if you would pause this thing and see what you come up with. So AEB bisects DEC at E, and we know that because it's given. And it says the definition of a bisector. So AEB bisects DEC. So I think I can say DE is congruent to EC because that's the definition of a bisector. They got cut in half. I know that angle A is congruent to angle B because that's given. Some vertical angles here. Well, I can say that angle AED is congruent to angle CEB because they're vertical angles. And then finally I can say triangle ADE is congruent to triangle BCE, and that looks like the case because of angle side congruent. So today had 5 pretty simple proofs. I hope you played along and tried those for yourself. If you did, you probably were pretty successful. If you didn't, for shame, for shame.